Well, hello again everybody. As you can see today I've removed all the capacitors from the power supply and we've got some new ones. Now while these were out I decided to do a quick sense check on them using my ESR meter, and we'll just do one now. So this is one of the old capacitors and you can see it's a multi-legged jobby, and it's got 5 pins on it, labelled, where is it now, 1, 2, 3, 4 and 5, and actually only 2 pins are connected, so which is 1 and 5 on these. All the other pins are unconnected, they're not connected to each other or anything else. I think some people have said that these multi-legged arrangements are used to perhaps improve the grounding, but I did look at all these capacitors, various data sheets on DigiKey. I looked at these and also the pattern that's just got the 4 studs on it, and all of them show the other leads as unconnected. So I think that's a bit interesting. So I'm guessing these can only be for mechanical holding. Anyway, let's just test one of them. I've gone ahead and done them all, but we'll just do one again. Okay, so it's saying 484.4 microfarads, and these have got an ESR of 0.1 ohms. Now, I struggled to get these 5-legged varieties. In fact, the only ones that I could actually find were on DigiKey. So I went ahead and ordered them on DigiKey, and then I had a sudden thought. Well, that evening after I'd ordered them, I came home and I did the ESR check on the capacitors, and I saw that it was 0.1, and it's 0.1 for well, actually all these are very good, 0.1, 0.08, 0.1, 0.09, 0.08. So I would say the ESR of these old capacitors is incredibly good, to say that they're 30 odd years old. I'd ordered the ones on DigiKeys and I just double checked the ESR value because I thought, that's pretty bloody good, that. And the ones I'd ordered were 0.2 ohms. So I'm afraid I cancelled them because I thought there's no point in putting a capacitor in that's got a higher ESR than the old ones. I could only get something appropriate from RS Components and in the UK. So I've gone to this 2-hole pattern, and as much for the mounting style and stud size and everything else, I chose the ones that were 400 volts. So these are 470 microfarads at 400 volts, whereas the old capacitors are 470 microfarad but 250 volts. My thoughts are that more voltage is better than less voltage. I'm not selling myself short by having a higher voltage capacitor. I think that, and you can see that even the higher voltage ones are considerably smaller than the original 250 volt units, and I guess that's just capacitor technology as it's improved in the last 30 years. But yeah, one thing I'm a little bit concerned about, if we just test these again then, we'll test one of these. And this one's 407 microfarad. So consistently all the new capacitors that I've got, they're reading about 70 microfarad low. Now, I don't know whether or not that will make a difference in this application. I kind of suspect not. But I just think that's interesting. Why are all these capacitors low? I was trying to explain it away in my head, and I'm kind of wondering, is there any kind of like burning period for new capacitors? When these are switched on to a proper, when they have some proper supply voltage across them, will the aluminium oxide, whatever it is, will the oxide layer reform and actually increase the capacitance value? I kind of think not. I'm kind of grasping at straws there. But this EPOS brand, it's a top brand of capacitor. They're all brand new. I just think that's a little bit strange. But I have to admit, I don't generally make a habit of testing new capacitors when they arrived. I just wanted to double check the ESR value, so that's why I did it. I know that old capacitors tend to increase in capacitance as they get older. And in fact, if we actually look at these, the old ones, you can see that I measured 508, 597, 500, 496, and 496. So these were all about 30 microfarads higher than they should have been in the specification, whereas these are all 70 lower. So I don't know what's going on there. If you do know, please leave it in the comments. So the cause of all my woes with this spectrum analyzer was the failure of these TVS diodes, which are basically just a Zener diode. And so I've got new ones, and these are actually, I think they're like the Zener voltage, if you like it. They're 188 volts. It says 185 on the actual on the instruction manual, on the circuit diagram, but these diodes are actually 185, so I'm not quite sure where the difference is. Maybe it was a misprint in the original manual, but this was the original cause of all our problems. So I've done the usual thing and printed off 3 parts of the circuit diagram at work using the photocopy and sellotaped them all together. So much for the paperless office. But here's the circuit, and what we've got here is these are the main smoothing rectifiers, the main smoothing capacitors, and you can see these TVS diodes across the capacitors. And I've got to admit, I'm not exactly sure what the purpose of the TVS diodes is. I'm not sure what purpose they serve, because if you actually do a little bit of analysis of the circuit here, the voltage across the capacitors isn't 188 volts. It's considerably lower. I think it was I don't know, it was 160 something like that. Can't quite remember what it was, but basically it's a lot lower if you calculate it. So under normal action, these diodes just sit there doing absolutely nothing, and I guess they're waiting for, like a high speed, what do you call it, a high voltage transient. And if that comes in, you get a spike in the power supply, and these diodes will clamp. And I suspect what happened is one of these diodes clamped, which probably killed it. And then because this is a short circuit, effectively doubles the supply voltage across this bank of capacitors, and doubles the supply voltage effectively across this diode here, which also then clamps. So one exploded, then the other exploded. Unfortunately, they failed short circuit, which a few people have said is the typical failure mode. So when they went short circuit, it caused the fuse to blow. Quite an interesting power supply, this. The way it works is, you can see there's a few things going on here. You can see that there's a transformer arrangement, if you like, but that isn't actually really part of making the power. What that's actually doing is it's driving the gates of a pair of MOSFETs, and effectively these MOSFETs are pulling these output lines high and low. It's putting high and low voltage on, and that goes to the next page, and that feeds into what I would call kind of a conventional transformer. So I don't know if you class this as a switching mode topology or not, because it uses effectively a standard configuration of step-down transformer, but it uses a smaller transformer. So what they'll be doing is basically transformers are sized really according to what current they're outputting, and also the frequency that you work at. If you need to pass so much current through a transformer, it physically has to be a certain size for a certain frequency. So at 50 Hz you would have quite a big transformer. But if rather than supplying a transformer with 50 Hz, you supply it with, I don't know, let's say 400 like they do on aeroplanes, aviation systems, what you can do is you can actually reduce the size of the transformer. You don't need to put so much iron in. In fact, you tend to use more like ferrite materials, things that can change the magnetic flux direction much faster. So what they've actually done is, rather than using like a 50 Hz transformer, they're running this transformer at higher frequency. I don't know what frequency they're running at, I haven't looked, but let's say 400 Hz, and that allows them to build a much tinier, much smaller transformer. But quite an interesting design. I'm guessing that some of this is done, it's done this way really to give the machines much better isolation. Maybe it helps it reject noise and stuff like that, but don't exactly know. Now luckily this circuit board has a multitude of holes drilled in it, so it looks as though that they do give you an alternative pattern for mounting these capacitors, and the pitch of these leads was 10mm, so hopefully that's what I've bought here. And of course we've got to be very careful that we get them in the right way around, because that could be messy, couldn't it? That's a bit sluggish taking solder. Old boards, might put a bit of flux on there. Right, I'm relying on you guys now to tell me if I put one in the wrong way around. So that's positive, so that's negative. You know, I once put some capacitors and I was looking at that band and I put them in and I switched it on and it went bang in my face, bloody thing exploded. And when I looked again, rather than the stripe on it being negative, like this has got the negative symbol on, when I took a close look, it actually had positive symbols on it. What a prat. You guys at home, just switch your extraction fan on while I'm doing this, will you? Don't want any of you suing me. Okay, so that's 2 in, negative, there's positive, 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 negative, negative. Yep, so far so good. In fact, they're all lined up in a line, these, like good little doggies, aren't they? Okay, so negative. I'll splodge your flux before I forget. Now, looking at the circuit diagram, I'm pretty sure that the problem was caused with those TVS diodes, so hopefully nothing else has been damaged or exploded, but I don't think it's a stupid idea just to check the drain and source on these switching MOSFETs. I had to look at what these devices are. They're N-channel MOSFETs. I'm not going to test them properly. I'm just going to see if there's any gross shorts on them. I will have a look at the drain to source. 500 ohms. Other things are in circuit. Looks about right. Source to gate. Okay. It's a reading, it's not a short circuit. That's all I really care about. Source to drain. Some diode action going on there. Fine, good enough. Right, we will put these naughty diodes in now. Hopefully these aren't going to be naughty diodes. Hopefully these are going to be good diodes and work wonderfully well. I don't suppose it's really necessary to use flux, but I have started using it more and more on my repairs, because sometimes when you use a bit of this liquid flux, it just makes the joint form a little bit quicker, and when you're working on circuit boards that might be a bit precious, you don't want to spend all day heating the things up. You know, you want to get in and get out, don't you? So we've gone ahead and put our capacitors in and our diodes, so I'll just wipe any flux residue off and then we will reinstall this. Well, it's going to be interesting to see if I can get this jigsaw puzzle back together, isn't it? Hopefully we can. Washer, spring washer, nut. Only about another 40 of them to go. I did have a collection of small nut spinners somewhere, but yeah, fortunately I seem to have mislaid them. I noticed Def Pom treated himself to a load of nut spinners the other day, and they didn't look bad. Although I did see them and they looked as though they had aluminium handles on them, and I don't like tools with aluminium handles. One, because I'm always a little bit worried about, you know, putting them on something that's potentially live. Because occasionally I do work on live stuff. And the other reason I don't like them is because I think they make your hands kind of a bit sweaty. They don't feel very nice in the hand. I could be wrong, I didn't have a close look at them. I think Scott said he liked them, so yeah, there you go. If Scott likes them, fair enough. Oh, bloody hell. I wish I'd take a closer note there where them pillars went. Oh well, I can always review my previous video. Right, looks like the pillows went
and just pressurising and
there
pressurising and then
and
going off
there.
like a grenade. So it is a designed in weakness.
So of course, got one of them in the wrong place, had to, didn't I? So, take that off. I apologise, my bench is a little bit messy. I should be a bit tidier, shouldn't I? Probably not very nice for you guys to look at all the mess on my bench. So that goes there. Plug the fan connector back in, which is I thought I put a mark on there. I did. There's a mark. Fan connector. Don't want to forget the fan. This fan is really strongly. It's not plastic. It's made out of you know, die-cast aluminium or something. It's very very solid. I've had a look at the other capacitors and yeah, well, I think Scott with his X-ray eyes at DEPOM, he's going to say that's bulgy, but he might be right. It'll do for today though, hopefully. The other capacitors look fine. I've got this big D-cat type connector on the back here which feeds power to the other modules. That's got a couple of screws that have to go in it, so we'll put them in as well. They're only going into plastic, so I'm not going to rive on them. Don't want to risk breaking that after all these years. Can that be a bit tighter? That's okay. That's okay. Earth. Don't want to forget our earth. And there's a spring washer lurking on the end of here waiting to drop into something. So let's sort him out. A lot of these unfortunately don't seem to have anything written on them as regards what they are. Does that say M6? What does that say on it? I don't know. These are that, what do they call that? I wanted to call it beryllium copper, it's not though, is it? It's them tools which are incredibly toxic though. They're designed to be spark proof, non-sparking. 6BA, that's not it. What's that one? 8mm, is it 8mm? No, smaller than 8. I'm going to have to go make a point of labelling them up, that's another BA. Well, it looks like all these copper materials, these are all BAs. BA. I've got some metric ones lurking somewhere. Oh god, well these are those X-Lite ones that smell as though they've been up the cat's bottom. They're really good little drivers, but they absolutely stink. Yeah. I'm doing Nelly. Not my days, these sockets aren't deep enough, it's getting caught on the stud. See, that's it, so I've got a 7 spanner there. Has anybody found anything that a 7mm spanner actually fits? I don't think anybody. I mean, oh. Alright, okay. It fits that, yeah. Alright, got this little strange little plastic shield, which I think it's some kind of separator between our two MOSFET power transistors. So, in theory, you don't need to take the screws off to get that on. He said in theory. There we go. See, these capacitors must be good because they come with already with a bulge in them. Part 1. Right, okay, there was a power connector in here, mains power supply cables. Gotta get them in. Got that aligned correctly. Sorry, excuse my big head being in the way. Yeah, PLB, PLB. Right, so kind of wondering, would it power up at that? I don't know if it'll need some enable signal from the microprocessor. We might have to install it, I don't know. Might as well put the fan cover back on, seeing as we're there. Now this just looks like a normal bit of mesh actually, but there's actually some RF magic going on here that some of you might not be aware of. What you'll actually find is that the mesh on these things are actually a particular thickness, and it's particular thickness, and they act a little bit like, I was going to call it, I want to say waveguide, but I don't mean a waveguide, I mean a cavity. The depth of the mesh acts like a cavity, and you get a standing wave at particular RF frequencies. So what they typically do is they will actually choose the mesh on these things to actually block out certain bits of EMC that might be being emitted from the machine. So there's some RF magic there. Well, now we've got it assembled, I think until next time that'll probably do. No, I'm only joking. Go on, I'm not going to be that cruel. Let's get it plugged in. I have to say I'm not feeling particularly confident because you've got to bear in mind I am an idiot. So it slides in from the back here. I'm just wondering if I should, rather than slide it in, if it'd be better to drop it in, because I want to see these connectors, make sure I don't crush them. Okay, I don't think I need to worry about those connectors being trapped, but I do have to line up the mains on and off control with this control shaft. Don't know if you can just make that out on the camera. There's a bar here. It's the on and off turny thing, and it has to line up with the actual switch. Pain. What an absolute pain. You can tell what a big girl's blouse I am, can't you? Because you look at Simon Spears and Def Pom and that, and they do these incredibly complicated repairs. I mean, really great work, and here's me making a fuss about changing effectively 2 diodes and 4 capacitors. There was hardly any cunning fault finding employed, was there? It was basically, let's just replace what's exploded. And it's funny, my last few repairs do seem to have been a bit like that, don't they? We had those tantalum caps that had gone bang, and it was perfectly obvious. I think with just a little bit of looking around, it was fairly obvious that these diodes had gone bang. So yeah, not exactly highfalutin, high-powered fault finding, was it? I guess it depends what you get used to, really. I don't actually repair that many things. I think I've joked in the past that I like collecting test gear, and a lot of the test gear that I repair is expensive, so the only way you can get it is you buy test gear that's broken, and then you have to repair it. And I am the reluctant repairman. I would like just to have my all my test gear, just buy it and it'll all work wonderfully, and I'd never have to lift the cover off, and I could just spend all my day playing with my test gear and never having to repair it. And I think I could be quite happy with that. I don't think that would bother me too much. I know some people would say, where's the fun in that? And they're probably right. Where's the fun in that? Right, I don't seem to have any parts left over. No, just 2 dead diodes. That worries me that we have nothing left over. Ah! That's why that fan's rattling. Right, I'm not going to make you watch that. Just, I wonder if somebody made it and then thought, these fans all rattle, what can we do about that? I know, we'll just put a plastic shim in. Of course, we still don't know why those TVS diodes actually decided to explode in the first place. I wonder if there was kind of just some inherent weakness in them. Did we have some kind of mains event that caused them to latch up? Did we have a spike on the mains? I was kind of thought I was going to have a spike on the mains. I would have thought they would have gone at the point I switched the instrument on. And, you know, the equipment had been on for a few hours when it decided to explode. So that doesn't seem completely likely to me. So I'm not, you know, I'm not exactly sure what happened there. Well, I needed a beer to calm my nerves, and that one didn't seem to do the job, so I had 3 more to see what happened to the first one. So I think we're now just about ready to switch this thing on. So I would give it 50-50. I have to reach over and switch the power supply on. I think the power's off there. Power is off on the, so let's quick buzz. So we've got a fault light overload an RF unit, but we haven't got the RF unit plugged in. So, does that mean we have to plug the RF unit in? I suppose it could be a power supply fault. We might have another fault on the second half of the power supply. That's disappointing. That I was really hoping that was going to fire up. Let's quickly just try and plug the other unit in just to see if maybe that's what it's missing.
Streaming to